Okay, so welcome to the Sandwich200 version 2 upgrade. This is a replacement of the Core XY kinematics with the unknown Zilikinko plotter arrangement, which I modelled earlier with string and bits of 3D printed plastic as bearings to scale to check it. So you can see here on the carriage we have 1, 2, 3, 4 bearings. So there's 2 for the X and 2 for the Y. And the belt arrangement comes from here round to this, up and down, and that gives you a double pulley arrangement. And it goes across this idler to there, round, and that gives you, that's a GT216, goes up there, round there. Then there's another pair of idler bearings in here. It comes down all the way down here, round that one, back there, and then it's at a fixed point there. And likewise for the other one, it comes from there, round a single idler there, all the way round this one, round that one, and it's incredibly tight. There's about 2 millimeters on there, between there, when that bearing is up there. Goes down there, round there, and fixed. Apologies, it goes there, round, up, and there. So now organising the rollers. Organising the heights has taken about 3 days to get right, because of the very complex height dependencies, because I'm using these will be Delrin rollers. Now X travel, if I replace that with a 0 and rebuilds that, it will move over. There we go. Alright, so on here, that's one of the ones for the belt. This one's clamped on there. Now what I've had to rely on is I can't fit a third one down here. There isn't just enough space, so just relying on 2 on this one. And if I go and replace that one there, move it over there, move it around, but there are 3 on this one, so it's 3 there, which stops it rotating a bit there, and 2 which clamp on here. So unfortunately what I'm relying on is this rod not wobbling to keep that steady. I just have to see how it goes. I can't fit a third bearing there. What I might do instead is perhaps try moving that up, so put an extra one. That one will go there, and we'll try and fit this one just underneath here. But you can see the height differences in these two. There's the one belt the bearings are there, and one belt the bearings are there. And the rods have had to come, the X and Y rods with the linear LM8LUU bearings have had to go offset by about 12 to 15 millimeters there. And I've set the X rods at the same height here. The square rods, they're the same height, exactly the same. Centers are on the same level as their corresponding fixed rods with the linear bearings. I've also, because we've got it's 240 millimeters plus and minus, and this is 312, and that's about 50 or 60 wide. It's unbelievably tight. I can't change. I haven't got time to change the frame for this version. So I've had to put a cutaway inside there to fit the edge of the bearing. Alright, and the belt will loop round that on there. So that happens on all 4 sides. That's to reduce the length of the belt that we need, because again I've got a 3 meter belt. It's been cut to 1.5 meters. That's what we've got, that's what we use. So this green part, that's fan holder, that's from the version 2 with the Core XY, that is going, and I'll be replacing that. We've actually now got plenty more room underneath inside here to put these fans possibly down on this right hand side here, and yeah, there's just enough room to fit the fan on there, and it will be able to fit the one for the hot end. We'll point that way at it. I'll split a 45-degree angle, double 45-degree angle, so it will be that way at a 45-degree angle, and also that way at a 45-degree angle. Bear in mind, this is a Flex 3 drive, which has to be removable because it's a folding printer, so it has to fit in. I think the box top, when it's stowed, comes here. There's not enough room for this. Remember, this is only one part of the Flex drive. You've got the part with the bearings inside it, and then you've got the actual flexible automated grade tube there. Now, this pillar is just to fit the belt holders. It's not got any idles on it because the belt goes round that way and round that way thing. So there's one bearing here to turn this one round, and that one bearing there. So there's a lower level there. That bearing. There's one bearing missing at the moment up there. There's a bearing missing up there at the moment, which I'll put in later. But it is. I mean, it's ridiculous. This is just so tight for space. The motors are on radically different levels. Replace 0, replace 1, rebuild. So you can see the offset something like, I think it's like 25 millimeters. So this is the motor shaft, and it's lined up with those. The other belt, it's completely mad. The other belt has to come in here. Right, so all this has got to, all the stuff on the other side of here has got to go. There's got to be a gap down the back here. It's got to fit just in between there. I mean, it's just ridiculously tight, but I can't rebuild the box. That's got to go over a little bit. You can see those are bashing together there, or that's got to be fixed. It's fine, it's not a problem. I'll just cut a bit of corner off of the edge of this one. And this one has the belt goes round there, round there. I think now it's worth showing you this one. X travel, replace 0, rebuild. Yeah, you see it's literally, it wraps around this one, and there's literally about 2 millimeters before it would go. Look at there. That's 2 millimeters between that bearing there and that one on the carriage. This is the best I could do. I don't want to take it too much further, because if you take it further you require more belt. I haven't got more belt. The 1.5 meters is it. It is very close. I have to take a risk that I'll get it right. The reason for the amount of time in doing this, as you can see from here, is things kept banging into each other. So this bearing, I had to offset in this way. I tried all sorts of ways. I tried that upside down, I tried that above that, I tried those, all the different combinations. This is the only one that would work, that would be reasonable. That rod kept banging into that bearing. That rod, likewise, if it was below there, But the most critical thing that affected whether to be able to do this was when this was lower down here. That I put down there, but that bearing there, that bearing which is for the belt coming in, would actually end up hitting this rod. So that's why all of these are this weird shape. Previously I had it, I think it was 25 millimeters, so I've increased it to 35 millimeters. When those bearings were there, the belt path would bash and try to go through the square rod. So in other designs, that bearing obviously is on the other side because this is much larger and the rod is in the middle and the carriage is over there a little bit and it's offset in the center and blah blah blah, and the printer's another whopping 100 millimeters larger than a 312 millimeter width. This is a 312 millimeter width and a 358 length. It's not 400, 450 like most printed designs. So it is meant that I had to stack things upwards, which has meant that I have height limits on the box and stuff to meet, so which I've just managed to get. I've had to lift this up by 7 millimeters compared to the version 2, but fortunately, because this is not a standard E3D V6, although in the CAD drawing here there's a standard E3D V6, I'm actually using a Volcano one, which comes to a huge another 10 millimeters further down. So, and the print bed, it comes up into the top area as well. So I've got, I think it was about 12 millimeters of play. So I've used 7 of that. 12 millimeters travel on the Z level to bring it up. So that kind of thing. So I've raised that up by another 7 millimeters so that bearing could fit and didn't smack into the Flex 3 drive underneath here. You can see that level there. All those bearings have had to fit underneath on both the left and the right hand side. So that fits just underneath there. All in all, this has been a pretty substantial CAD design project. It's all managed in Python using PyOpenSCAD. I am currently, I think, up to an incredible something like 11,000 lines of Python code in the design here. Something like over 50 parts. It is by no means, in its own right, it is by no means a small software project. Anyway, I thought you might appreciate that because it's going to be pretty amazing. I'm getting some 0.9 degree stepper motors, 2 amp ones from OMC Stepper Online. I'd be really interested to see if, as Dave says, DC42 said it should be possible with a duet to do 1,000 millimeters a second, as 1 meter a second with those, and I'm hoping to achieve that with this design. With the Volcano and the Flex 3 drive, I've already done tests of up to I think about 90 cubic millimeters a second of extrusion through that, and it's been fine. That was at 400 millimeters a second. It's just that the arrangement with the belts was just not good enough, so I had to go. Anyway, thank you very much.